In this video, we're going to talk about practice quiz for standard 4. It focuses on piecewise and inverse functions. Number 1 says use the graph below to write the domain and range of the function. So the first thing with domain is you want to look at what is the graph doing from left to right. So more specifically on this graph, it's going from negative infinity on the left, and then you see if all the x values are included. So the 1 is included even though it's open right there. It was closed on that quadratic function. And then we notice like none of the x values are missing from left to right. So we can say that all real numbers are included in our domain. Now for range, you want to think of it from the lowest y value to the highest y value. So the lowest point on our graph, the y value is 0, and it's equal to 0 because there is no hole in the graph. It's a solid line right there. So there's no reason to think it's not equal to 0. So we need to put 0 with a bracket since it's equal to 0. And then this graph goes up forever in 2 places, but even if it goes up forever in any place on the graph, it would go to infinity. And we put a parentheses because you're never going to equal infinity. And then for that third part of this problem, it says find f of negative 2. So if you think of f of x, you've seen that before. X is your negative 2. So you go on the graph and you look for where x equals negative 2. And so I go to negative 2 and I go to the graph. And that is the point negative 2, 4. So I just say that this is equal to 4 because you just need the y value. Alright, so that's it for number 1. Let's take a look at number 2. This one says write a piecewise function to represent the graph below. So you want to pick out the equations of these lines. So this line is just a horizontal line at y equals 2. So I'm just going to jot that down. You've already got y equals out front, so you just need to put the 2 on the inside of your curly brace. And then this second function is linear and it's slanted, so we need to pick out a slope and a y-intercept. So let's see. The slope of this line looks like it's going up to right 1 each time. So let's say the slope is 2 and the y-intercept is 1. So we would just put that together in slope-intercept form and say that is y equals 2x plus 1. We've already got y equals out front, so we just put the 2x plus 1 on the inside of our braces. And then we want to decide what part of the domain is represented by that part of our function. So we go back and take a look, and y equals 2 is between negative 6 and negative 3. So let's say x is between negative 6 and negative 3. It's greater than negative 6 and it's less than negative 3. And it's equal to negative 6 because that dot is solid. And it's not equal to negative 3 because that endpoint is open. So I'm just going to transfer that over here to my function now. And then this other graph, we take a look at that. Notice they share this fence at negative 3. So that's where this one starts. And the domain goes from negative 3 to positive 4 is your x value right there. Let me make that look a little better. So x is greater than negative 3 and it's equal to, since that dot was solid, and it's just less than 4 since that dot at the 4 over here was open. And again, I'm just going to put that over there with my function. Now a really good thing to do would be to double check in Desmos that that matches what you've got on your graph. So I'm going to type in my function I've set up here. I've got 2. I need to type that curly set of braces right beside it and put in negative 6 Looks like a less than or equal to sign. And then a less than, so type it just like it looks. And you notice that that does look like that little part of the graph that we've got so far. And if you drag your cursor, you can tell that one end is open and one end is closed, and it does match what we have over here in the picture. Okay, now let's try the next one. 2x plus 1. Add our brace, and then we put -3 is, it looks like less than or equal to, but it's really x is greater than or equal to. And then it's between -3 and 4. So we check and see if that matches what we've got in our graph. So you can compare some points, like this end point of this graph looks like it's located at 4, 9, for example, which is the end point over here. It's just open, or it should be open if it lets me. Let's see if it'll let me drag it. Yeah, so it's located at 4, 9, but it's undefined and it's open like it is in our picture. And then this one is closed and it's located at -3, -5, which again does match our picture over here. So then we know we have everything straight. We didn't have to tweak anything for number 2. So let's take a look at number 3. Number 3 says use the function below to find the function values. Now you can do this one of two ways. You can either type this into Desmos and pick out the values, or you can substitute them where they belong in the domain of the function. So let's first type it in so we can look at it that way. So I've got 3 to the x, and then I need to put, let me do that again, 3 to the x power. I need to scoot over and put in the curly brace and put x is less than or equal to -1. And then, let's see, we need to type 2 to the x minus 2, and then put the little brace beside that and put -1 is less than x is less than 3. It's really x is between -1 and 3, but they look like less than signs. We put the absolute value of x, and then we need to put our curly brace and put x is greater than or equal to 3. So you can type it in and pick these numbers out of your graph. So for instance, g of -3 is over here. Let's see if we drag it over to -3. It's kind of sensitive, so it's hard to get really close to that one, but we know it belongs in that purple graph. So I could go in here and type in a value of -3, and it'll give me the number that goes with it. So notice -3 is less than or equal to -1, so it belongs in that first function for that reason. And you could also just plug it in right there. So 3 to the -3 power is 1 over 3 cubed, which is 1 over 27, which matches that decimal you're seeing in Desmos right there. So we could say that's 0.04. Let's just round it off. All right, so then we take a look at 2. So 2 is on this middle function, and it looks like we can drag it over there pretty simply, but let's see. 2, it looks like, when you land on it. And you know it's in this middle function, so you can hit the table for that one and see that 2 does indeed go with 2. The other reason is 2 is between -1 and 3, so it belongs in that middle function, which is 2 to the x power minus 2. So we would say 2 squared minus 2 equals 4 minus 2. So there's two different ways to look at these. You can look on the graph and check what the value of y is where x equals 2, or you can plug it into the function where it's appropriate. But either way, you should get the same answer. So we got 2 for that one. Now this last question is actually asking you to add the g of negative 3, which you already found was 0.04, and g of 2, which you already found was 2, and just add them up. So you get 2.04 for that one. All right, so let's take a look at number 4. 4, we just have to graph. So let's clear out Desmos, and definitely we could use that to help us out. We could go ahead and draw the fence like we've talked about in class. The fence is located at the 2. So that helps us line up our graph in the right spot after we get it typed in. So let's see. I think I do need y equals because it only has the negative 6. There's not a variable with it. But let's see. Then we just need to put in x is less than 2 for that one. And then negative 2x plus 3. That one has a variable with it, so you don't have to put any other like y equals, but you can. And then x is greater than or equal to 2. So they line up at the fence. We can see that this one is open at the fence and is just located at negative 6. So I'm going to transfer that to my graph. So at negative 6, I come over to the fence and I put an open circle, just like it looks in Desmos. Now let's check this one out. So this one has a solid dot at 2, negative 1. Let me go to 2, negative 1. And then we just need another good point to graph. So you could easily pick out the table if that helps. Let's see, there's 2, negative 1, 3, negative 3, lots of good points. Let me do another one. 4, negative 5. I like that one. 4, negative 5. And then just sketch a line. And that is it. That's all you have to do for that one. And number 5 says find the inverse. So I'm going to move Desmos out of the way. We have to start by switching x and y. So we take f of x, which is like y equals, so we could just rewrite it as y equals 3x squared plus 4. And then you want to switch them. So you would say x equals 3y squared plus 4. Everything stays the same. The x and y just trade places. And then you just want to solve for y. So let's try to get y by itself. I would subtract the 4 first, so you get x minus 4 equals 3y squared. Then divide both sides by 3. So divide the whole x minus 4 by 3. Make that a big fraction bar right there. And then you have y squared, so you need to take the square root of both sides to get y by itself. Remember, even roots need plus or minus. So when you're solving and you take the square root like I just did, I need to put a plus or minus out front, and then x minus 4 over 3 would still be underneath. And then you just want to put that little negative 1 to label it correctly, because now you have found the inverse. And that is it. All right.